Welcome to DP Tutorials by Donny Jerwa. In this teaching lesson, we will emphasize and enunciate on factors affecting resistance. And from here, we will establish one relation which is known, or one term I may say, which is known as the specific resistance or resistivity of a conductor or of a wire. Now, what is resistance? The resistance is nothing but the opposition to the flow of electrons, or the opposition to the flow of electric charges. So we know that when electrons flows inside the wire, it will be obstructed. The motion of the electrons will be obstructed and they will collide among themselves. This condition, or this opposition to the flow of these charge carriers inside the wire, is known as resistance. And resistance arises because of this collision between the electrons. Now the symbol is given by this. This is the symbol of resistance. And resistance also depends upon two core factors. Number one, it directly is proportional to the length of the wire. Directly proportional to the length of the wire. So from here, when you look from this diagram, when you look at this first conductor, this is the first conductor, the second conductor, and as well as the third conductor. Now, from here, when you look at these conductors, suppose when you look at these conductors, the lengths are different. The lengths are different. So from here, those are the lengths of these conductors. And even the area of cross section is also different. I can write as A1. I can write the area of cross section of the second wire as A2. I can write the area of cross section of this third wire as A3. Which means that when you look closely, suppose when you look closely into this geometrical construction or geometrical shape, that means from here, if there are electrons, if these are the electrons, that means if there are many number of electrons, and if this is positive, and we know that all these electrons will move towards this side of the wire. Now, as the length increases, resistance also will increase, which means that R is directly proportional to the length of the wire, according to the first condition. Now the second condition. Now, as the area decreases, which means that as the area is very small, so the resistance will be large. And as the area is large, when over here there are electrons, and electrons can move swiftly. Suppose if this n is positively as a positive potential, then all these electrons which are negative, they will move towards this end of the wire. So which means that over here, resistance is inversely proportional. Resistance is inversely proportional to the area A of the conductor. Which means that as area A decreases, resistance will increase. As area A increases, resistance will decrease. This is the meaning, which means when R is large, our resistance will be large only if the area is small. More electrons has to cross, so there will be more resistance. And resistance will be small, or will be less, when the area is large. That means when the area is large, more electrons can move freely, so resistance will be small. So these are some of the cases where we have to consider, and make sure that all these resistance that we have taken will be in the form of conductors. Conductors available will be in the form of might be in the form of aluminium, copper, gold, and so on and so forth. So if we combine these two relations or these two conditions or these two factors, we can come to an important equation. Okay? R is proportional to this is L, and this is will be what? This will be E. If we combine both these 1 and 2, if I name this as equation number 1, and if I name this as what? As equation number 2. From 1 and 2, it implies that this. And in physics, we have to remove this proportionality sign. We have to remove that proportionality sign by writing what? By writing equal sign and a constant of proportionality. We'll put the equal sign and the constant proportionality. This constant proportionality is written by rho, and this rho is what we define as the specific resistivity. Okay? Specific resistivity or specific resistance. Okay? Specific resistance. So what is this rho? This rho is what is known as your specific resistance. Rho is the constant of proportionality known as the specific resistance. Specific resistance. Or it is also known as resistivity. The other name for specific resistance is also known as what? Resistivity. The value of resistivity of a particular material indicates the resistance of the conductor. If the resistivity is large, okay, resistance of the conductor is large, and if the resistivity is small, that means resistance of the conductor is also small. Now, when you compare between these data, okay, now before we compare some of those data, let me first write something. Okay, so this is the formula for the resistance of the conductor, and from here we can write the units. Okay, the units of rho. What is the units of rho? SI unit of rho. The SI unit of rho is what? The SI unit of rho is ohm meter. Ohm meter. So you can establish from there. Okay, this is rho. SI unit of resistance is what? What is the SI unit of resistance? SI unit of resistance is ohm. Then the SI unit of length is meter, and area is what? Meter square. So this one and this one will get cut. So you get this rho, the SI unit of rho, cos multiply m this side, so you'll get what? Ohm meter. Ohm meter. Then these are some of the important features, and now suppose if we cite an example, okay, for cylinder, let us compare between two types of material, suppose such as copper. Okay, copper. This copper Cu, suppose if rho Cu be the resistivity of copper, when you look at these data, it will have the resistivity of this much value. Okay, this is for copper, 10 to the power minus 6 ohm meter, and the resistivity, okay, the resistivity of suppose like silver, okay, e.g. silver, then this resistivity of silver will take the value of 1 into 10 to the power minus 6 ohm meter. Now when you look at these values, okay, when you look at these values, it is very clear that the resistivity of copper is more than the resistivity of aluminium or of silver, I mean, okay, of silver, which clearly indicates from these values 1.78 is more than 1. So from here, copper has a larger resistivity than silver. So if copper has larger resistivity than silver, which means that that material which have the smaller value of resistivity, this material which have the smaller value, so this will be smaller. So when that is smaller, it means that this material is what? Is the best conductor. So if you want to get good conductors, the resistivity should be small. So on the basis of resistivity, we can classify materials into different categories, okay, into different categories. So on the basis of this resistivity, we can classify, okay, we can classify materials into different categories, okay. We can classify materials into different categories. Like we have conductors, okay, we can classify these materials into different categories. We have what we call as conductors, which is this example, okay. We have what we know as conductors. We also have another type of material which is known as semiconductors. We will be learning this in another teaching lesson, okay, on the basis of this conductivity. Then on the basis of this resistivity, also we have the third material which is known as what? Which is known as the insulators. So all these three materials, okay, this is number one, this will be number two, and this will be number three. So on the basis of resistivity, okay, on the basis of this resistivity, we can classify materials into three different types, okay, conductors, semiconductors, and insulators. Now also we should know that if when you look at these conductors, okay, when you look at these conductors, that means resistivity is small. So always conductors will have small value of resistivity. Now there's another factor, okay, which is known as, if you take the reciprocal, if you take the reciprocal of resistivity, we define this as what? As conductivity. Okay, we define this as conductivity, denoted by what? Denoted by sigma. So this is what is known as your conductivity, the reciprocal conductivity. So what is this conductivity? Conductivity is nothing but the reciprocal, okay, the reciprocal of resistivity, okay, reciprocal or the inverse, okay, the reciprocal or the inverse of resistivity or specific resistance, okay, resistivity or specific resistance, that is defined as our conductivity. So this conductivity will take the formula of sigma equal 1 divided by rho. And the units, okay, the units for this conductivity, the units for this conductivity, so the units or the SI units, since previously the units for rho is ohm meter, so over here it will be what? Ohm inverse meter inverse, or in short we write as what? Mho inverse, or we can write in another type of unit which is known as Siemens. Okay? Siemens is the SI unit. Siemens is the SI unit of what? Of our conductivity. Siemens. Another form that you need to know is that when we take the reciprocal of resistance, okay, when we take the reciprocal of resistance, we get a term which is known as by G. This is known as your conductance. Okay? Conductance. So what is this conductance? Okay? Conductance, all it ends with TNC, conductance and resistance. Okay? This conductance is nothing but the reciprocal, okay? the reciprocal of resistance is defined as conductance. And the units, okay? the units for this conductance, since the units of resistance is ohm, the unit of resistance is 1 ohms. So from here it will be ohm inverse, or you can write as you just spell this in the opposite word. It is written as MHO, okay, Mho, ohm inverse, or MHO inverse. Okay. So these are some of the certain features that you need to have a clear concept about what is this resistivity. So this resistivity is the foundation, okay, foundation for understanding the concepts of materials. Okay, materials are classified into different types. All materials in nature are classified on the basis of what? On the basis of this resistivity. Okay? Conductors, semiconductors, and insulators. Okay? When the resistivity of the material is small, it means that it is the best conductor. When the resistivity of the material is large, that means it is a bad conductor or an insulator. Okay? Just go through those teaching lesson and try to comprehend from there so that you will get a clear picture. Thank you.